Меня зовут Дима. Я немного расскажу о себе, что когда мне было 11 лет, мы переехали из Сочи в Америку, так что с 11 лет я в основном говорю на английском, и поэтому мой русский немного отстает. Если что-то непонятно, переспросите, я повторю себя, иначе у меня язык просто не поворачивается в общем. И если вот моя информация мне нравится, все вкусно, все. Мой Twitter, и я иногда пишу на мой блог информацию там насчет в основном тестинг и какие-то информации на Selenium в основном, и continuous integration, как Jenkins, такие вещи. Мне нравятся бесплатные вещи, я не люблю платить, и поэтому я в основном говорю о том, что бесплатно. Некоторые компании, на которые я работал немного в Stone 5 лет, и теперь работаю в компании Groupon. Для тех, кто хочет мне зарплату платить, вот сайт, пожалуйста, идите купите что-то. Зачем я приехал? Я люблю сало, я поэтому сюда и приехал, потому что здесь этого в Америке сильно нету, особенно сала. А рыбу они не любят. Так что, я хочу поговорить о зеленом или билде. Именно идея, что тесты всегда должны быть зелеными, все должно быть хорошо. И потом, почему нам надо, чтобы всегда было зелено, чтобы потом автоматически делать merge, когда новые добавляют информацию в Git, и автоматически отказываться. Я сильно не делаю немного расслабленно, так что если у кого есть вопрос, пожалуйста, можно разговаривать со мной, и в конце больше вопросов будет. Так что, в основном я начинаю с того, что меня всегда спрашивают, зачем нам нужны автоматические тесты. Они очень дорого стоят, чтобы их написать. Иногда, чтобы написать большой тест, sweep, оно будет стоить то же самое, что и саму программу написать вначале. Потом занимает очень много времени, и они постоянно ломаются. Все тесты почему-то постоянно ломаются, нету такого, чтобы тест всегда был зеленым. И последнее, почему нам нужны тесты, если мы их не можем продать и не можем с них денег получить, то зачем их писать в первом месте? И в основном мой ответ это, во-первых, если есть хорошие тесты, это у вас в компании есть здоровый вид жизни. Вы занимаетесь и спортом занимаетесь и работаете. Пошли дальше. Иногда шутки просто не переводятся.
Можете на английском. Да, мы можем понять.
Понятно. When you have confidence in the code base, it's a very, very good thing to have. That when you change something, and you can change it quickly, and you can change one line of code and not worry that somewhere down the road something else broke. When you have that confidence, it's just easier to work, and you don't have to worry about as many things in life. So it's very enjoyable. You actually start to enjoy the work instead of it being like oh, this is another thing I have to get up in the morning and go to. You just start to enjoy it, and it gives you ability to when you have confidence in your code base, it gives you ability to release code fast. It gives you the ability to say, hey, the customer wants a new feature, we can give it to them in 2 weeks. Because you have the rest of your application is solid enough that when you throw something at the wall, it actually sticks and it works pretty well. And finally, when things go wrong, it's very, very easy to see. Like, this is our current build, and you can see like right away, oh, somebody broke something. The rest of the time it's green. And in our situation, in our culture, when the build goes red, if you're free, you have to go fix it. Like, there's no such thing as, oh, Alex, Slow-mo. You know, you have to go and fix it. Like, whoever can do it should do it. And it doesn't matter if you're on the wrong team, because this build right here is many teams working together, and this is the overall tests. And it doesn't matter which team broke it. Whoever is available to fix it should go out and fix it.
So no personal responsibility.
Everybody has responsibility for the whole
But
thing.
this means that no one has responsibility.
It means that nobody owns it, but everybody owns it at the same time. It's like, I feel responsible that even if I didn't break it, I'm gonna go fix it for that person. I'm gonna let that person know, hey, you broke this thing. That person usually starts to feel guilty. And guilt actually works pretty well. Like when somebody breaks the build and didn't fix it like 3 times in a row, they hadn't fixed it. Usually saying, we use a chat room called Campfire. And in Campfire, hey Alex, you broke the build. It's like, oh, sorry, I'm gonna fix it now. Like it works magic. Like when everybody knows that you're the one who broke it.
No pink hat.
Huh?
Without any pink hat.
Without pink hat?
Yeah. For the person who broke the build.
Well, in one company we had a rule that if you broke the build and went home, the next morning you have to buy everybody breakfast. So.
I think it should be better it should work better than just guilt.
Well, it is guilt plus punishment. I mean, when guilt alone is not enough to pay money for it. So, if things go wrong and you can see it early on and you can fix it right away, you can reduce the amount of bugs that are released, which just in general, yeah, it is a hard sell at first, but when to your manager. But when a manager can see that you consistently can deliver code that is very good from the beginning and only has a couple of bugs instead of, there's certain applications out there that Google Buzz came out 3 weeks. It was off because there's so many bugs and so many problems, and they didn't even think about everything that could go wrong, and it went wrong, and they had to pull it off. So if you can fix the problems right away, you're going to save a lot of money in the long run. So I'm going to assume that you guys know all these words, which is awesome, and I'm going to just skip right through them. I want to quickly talk about continuous deployment. So we, at Groupon, we don't do continuous deployment. That word is a very scary word for some people, but we deploy 1 time a day, every day, and sometimes 5 times a day, every day. But on average, we release 5, 6, 10 new features to the customers every week. So basically, whatever is in the trunk every week goes to production. And then the rest of the week, if there's any bugs, we just fix them and push them out the next day. So we have this idea of like, oh, you have a bug today, don't worry, we'll fix it tomorrow. It's not a big deal. You can just kind of, everybody relaxes and feels better instead of, the whole time. So, but this link here, it talks about a company that does 50 deploys a day. And they can do some crazy things because they deploy so often that when something goes wrong, they can just say, oh, let's go just 1 more version back and everything will be all right. It gives them ability to experiment things that they can spend 2 weeks building a new idea, and when it doesn't work, they throw it away, and you only waste 2 weeks. You don't spend a couple of years like Microsoft did with Bing. You would spend so many years, and nobody uses it. Everybody still uses Google. Nobody's heard of it being. The one thing though is everybody on the team, or majority of the people on the team, need to be in agreement with this. You cannot have just one person saying, "Hey, let's do this idea," and everybody's like, "Nah." Or if the manager says, "Hey, you have to do anything," there's going to be a lot of fighting, and you don't want that. So we got the basics. Okay, let's get the good stuff. So in order to keep your build always green, and in order to make your build actually mean something, first thing you need is it has to be very, very fast. It has to run all the time and run a lot. We right now build 300-400 times a day, sometimes depending on how busy the thing is. Thanks. Yeah.
Just one quick question. How much time do you spend to optimization of the build speed?
I'll get to that in a couple slides. Your tests need to be accurate, so that they fail when they should, they pass when they don't, and they should be really easy to read. And anytime you get a red build, like if I see that the person submitted something in one red, I just pick this change out and say, hey, you broke this. Like I don't believe in having more than 2, 3 builds in a row red. I've worked for one company where out of the 6 months I worked there, I saw a build go green 3 times out of 6 months. And that is, at that point, you don't need the test. Like, why even bother? It's just terrible. So I think that tests need to take 10 to 15 minutes to run. If they take longer than that to run, nobody's going to actually use them. When I started to do our current tests, they took about 90 minutes to run, and nobody really cared like for all the tests. So the idea there is that the test should run fast. You made us commit, change, committed, run the test, everything's good, keep going. To do that, you gotta run the test in parallel, you gotta split the tests up a little bit, and use other things like RAM disk and headless browser. And parallel test is a good start. So I'm gonna get into those things more in detail, but parallel test is a very, very good start. Like a lot of the new computers, they can support more than one test at a time, so why not use it? Even like this laptop, it's a couple of years old now, but I can run 4 Selenium tests in parallel and still do fine. If I run 6, it starts to catch on fire, but it's like during the winter time, it's like, I think my hands warm. And there's a lot of tools that will help you do that, but the one we use is a parallel test. It's a Ruby gem. It's very simple, and if you don't want to use a tool, it's just a simple thing. Just split your test in a couple of groups and then launch them in parallel. This will work for most people. So this is how we describe our tests. We have 300 cucumbers, 170, maybe closer to 200 now. Selenium in about 14,000 RSpec tests. RSpec tests we use more like unit tests. RSpec, it's basically like it's just a way of writing tests, very similar to Cucumber, but a little bit more technical. Do you know what Cucumber is?
No, really.
Okay,
So I know what is the tool, but not really.
Fair enough. RSpec is just a way of describing a test.
Like fitness?
Like fitness, yeah. RSpec is like one step after fitness. They took some of the ideas from fitness and took it into RSpec, and then they took stuff from RSpec and made Cucumber out of it. But it's just a way of writing tests. For us, RSpecs are very similar to unit tests and some integration tests. And Cucumber tests are a lot more integration, like, hey, make sure all the modules work across the board. In Selenium, we use it for end-to-end, like, let's start from all the way beginning to all the way end and make sure that everything works in between. So.
But unit test and integration test, is this just in the RSpec, or is this?
Yeah, they kind of live together in RSpec, and it's kind of like we're using the RSpec for both. It's just when you look at the test, you can actually know, oh, this is just a unit test and this is more of an integration test, because all it is just a tool. It's just like saying all my tests are written in Ruby or in Java, right? It doesn't really matter. So why not use?
Is this all stuff on the build server, on the CI, continued by one?
By what?
Who manages this amount of stuff for the tests?
So who maintains that?
Yeah, who maintains it?
Yeah, okay, so we do test-driven development, so a developer cannot commit new code unless he has 1 or 2 tests attached to it. You're not allowed to. There's somebody who will say, hey, you're not allowed to do that. I mean, if it gets really bad, you just say, hey, you didn't write any tests, I'm going to revert you from it. Because right now we have about 100 developers and only 5 QA people. And if we heavily rely on these tests to actually keep the sanity, because otherwise you will not be able to keep up. We want more QA people, but they're really hard to find the ones that we actually want to work with. And so that's the problems, and the solution is to just have more tests that are good tests. That way, when the build goes red, that's why everybody says, hey, let's figure out why it went red and fix it up and on. So Okay. But when I started this project there, basically, before, if we take all our tests and run them in one after another versus parallel, Selenium will take something like 85 minutes to run by itself. Cucumber would take 75 minutes, and RSpec would take, you might as well go home and take a nap. When we started to run them in parallel, though, it really dropped down our time. That RSpec only takes 11 minutes when you run it in 21 parallel tests at the same time. So it saves a lot of time. Now as a developer, I have an incentive to actually run all of the tests all the time because it takes 10 minutes to finish up, which is great. And yeah, so parallelization really works. We have very big machines though to do 21 tests in parallel. So they're about 24 cores and about 32 gigs of RAM, which is kind of expensive. But the way the company sees it is that if you have developers just sitting around for 60 minutes and doing nothing, that's more expensive because you're still paying them, but they're not actually doing any work. Whereas they trigger the test and they keep working, and in 10 minutes they know they broke something. That's much cheaper than all the time. The other thing though is if you do not have very big expensive machines, but you can get a whole bunch of cheap machines just like regular desktops, you can just split it across multiple computers and let the tests run themselves. So I had to do that later on. I will talk about it, but this is when I initially started, it would run on one computer in parallel. So all the RSpecs would run in parallel, then we would trigger Cucumber in parallel, and then we'll trigger Selenium. And basically, if you wanted to time it out, it would be almost still 2 hours to get any result back from the point of commit. Selenium is the slowest thing out of everything. So I looked for a couple of solutions. Jenkins allows you to run things in parallel, sort of, but it didn't really work for us. TeamCity and Bamboo allows it stuff too, but you have to pay for those, and those things are expensive. So I threw together a small script I called Jenkins Conductor, and basically the idea is you take one very, very cheap machine, and all it does is it triggers a bunch of builds and just waits for them to finish. And that machine can trigger 20 builds, 30 builds at a time, and once all of them finish, just pull all the tests together into one build and say, hey, everything is good, or no, Selenium broke. This really, really cut down on the amount of time that our overall build, when somebody commits something, it went down to about 14 minutes. Now when I commit 14 minutes later, I know that Cucumber, RSpec, Selenium, and Jasmine tests, all of them passed. So I feel more confident that, hey, the stuff I did actually works. I can move on to the next problem. So this is the link to it. I don't know, I wouldn't use it because I'm not a very good programmer, so the idea is very simple. I think you should probably write your own thing that actually works. My thing doesn't, so, but there's the link. There was another idea that Google posted on their blog. This is the link to it, but their whole system, their whole build, including Gmail, Google Search, YouTube, Google Plus, and a couple other things, it's all run together, and it takes a long time to finish it. So this is the way that actually looks, like all the things that are connected to each other. So their idea was, since they're using a lot of Uncover and all those other tools, they know that when I make a change to, say, Buzz up top, that only the tests that touch that stuff should run first. So run those tests initially and get them passing or failing fast. That way, if it fails in 5 minutes. And after everything is done, then run everything together at the bottom. So that saves them time because about 80% of the stuff that you push will break some test. So there's no reason to wait around that long. I used the application called Ramdisk. I believe it comes more or less free, but I think it's installed by default on Linux boxes. The Wikipedia page claims that it's even faster than a solid-state drive because of just the bus throughput and the speeds. But Ramdisk alone has really cut down our test for Selenium. We went to close to 40 minutes of running Selenium in 8 parallel ones to 20 minutes. And the reason that our tests were slow is because the test hit a lot of stuff that hit the MySQL often, and MySQL was bombarded constantly, MySQL was thrashing. So moving MySQL into RAM disk actually sped things up. Headless browser, give these guys a try if you want to get Selenium tests to run a little bit faster. Capybara WebKit, they claim that test that usually takes 30 seconds to run, they say that they will run in about 8 seconds. So I don't know about that. I haven't seen the same results, but that's what they claim. So I'll believe in this for now. So you need tests that are very, very reliable, that every single time you run them, you're going to get a consistent result. And this is the problem that takes forever to fix, especially Selenium tests. When you run them 2 times in a row, sometimes you're not always going to get the same result. And that's usually because Ajax doesn't load fast enough, or we had a problem with Facebook. We would bring up images from Facebook, and the Facebook would be running slow, and so then the web page would not fully load because Facebook hasn't loaded. And the test would fail. The test dependencies, if you have one test that relies on the other test, you should not have that. Each test should be able to run on their own. What somebody suggested is just run your test randomly, just switch them around all the time. That way you do not actually have to test which depend on each other. But a flaky test is worse than having no test at all, because it gives you a false sense of confidence that, hey, I have a part of my registration is covered, but it actually is not. And so when a test says everything is green, no, you're not going to take a look at there again.
What is flaky?
Flaky means nestabilny, means if you run it 10 times, 2 times it's going to fail, but 8 times it's not. Unpredictable, yeah. Again, Selenium tests tend to be the worst offenders of this, because there's so many other things that go on that you need to write your test very, very carefully, that you wait the proper amount of time for Ajax to load, or wait for the divs to load before everything fails. But I've got caught many times where you think everything is good, and code goes to the customer, and everything breaks, and then somebody looks at the test, and the test actually is testing something else altogether. It's not testing what you thought it was testing, which is very, very annoying. So a couple of tips for the Selenium to make them less flaky. Try to use IDs to click on things, or use divs, the class names, use XPath better, instead of just saying, full name, actually write into the text box that you want. Also check that the element exists. Like if you're going to click on a button that appears after 5 seconds and waits for Ajax to load, before you click, maybe check that it's actually there. If it's not there, wait a little bit longer. If it's still not there, then say, hey, something's broken. Don't just say click, because that will break it. And wait for Ajax is the biggest one, the biggest offender. Sometimes when I'm looking at a test that breaks once in a while, I have to do this. It's a very simple Unix command. Just run the test 20 times in a row and see how many times it fails. And sometimes out of the 20 times, the test will fail 1 time. But that 1 time is enough to confuse somebody down the road and say, oh, this test is so flaky that why should I even pay attention when the build goes red? So you need to get rid of those guys. They will poison your confidence in the build. And we just covered this already, so we just talked about they should fail when they shouldn't. Your test.
Just a simple question. If Selenium test is the slowest part of the system, if you run it 20 times in a row, it seems that it should be 20 times slower than even slow as Selenium test.
Well, what I mean is, like, when I see a Selenium test that failed in the CI, I run it 20 times on my computer to see how often it fails, so I can find out why it's failing once in a while. Like, I'm actually watching it, because when you're running it on Jenkins or whatever, you're not actually watching. But now I'm like, oh, it's because this button didn't show up, and we can actually see it happening. But it's annoying. It takes forever because you're just sitting there. But make your tests very easy to read and to understand. Cucumber is very good. I was talking about Cucumber with Joseph up there yesterday at this meetup you guys have. Who's Andre? Right here. But anyways, the idea there is that you write a test in Russian or Chinese or whatever, so that it's easy, like whoever can read it and say, oh, this test actually buys me a ticket. So you understand it, and that way you can actually understand which parts of your system are tested and which one not. Because when a developer writes a test, sometimes it's like you have to stare at it for 2 hours before you understand what on earth you're testing. So if the test is very easy to read and very easy to understand, it's like, oh, okay, this is what I'm testing. Same goes for RSpec. RSpec actually helps to make tests much more readable, much more easier to understand. But whatever tool you use, if you don't want to use any tool, make sure you're tested. Write them very simple and very clean. I worked with a guy who said that a test should be as complicated as the system it's testing, otherwise it's not a very smart test. And so nobody but him knew what the tests were doing. And so when something would break, he would be the one sitting somewhere in the corner going, okay, I'm gonna fix it. Because nobody else knew why the test broke. So the build would break and you have to go and talk to him, and he would sit there for 20 minutes and say, oh, okay, this is the reason that you changed the link name. It was just a miserable experience. Quick, simple tests, that's the way to go. This is that quick idea that some people at Groupon, we basically build up. We try our best to prevent a broken test to make it into master in the first place. So we're using Git, and we will use some branches and run tests against the branches. But if they fail, we don't let the person commit it to master. And so the system works.
You use GitHub, yeah?
Huh?
You use Git, yeah?
Git, yeah. We call the system, I don't know who came up with the name, but we call it any branch. So the idea that you push to any branch and tests will run. I don't really understand it, but basically the idea is very simple. So when I write a new test, I just push to a new branch name. If it starts with the word test, / and then you describe what you did, like I added a new customer, or I added a new page in it. Jenkins is triggered automatically. Oh, you can't see. Can you see that?
Oh,
I can turn the lights on.
it's not that easy.
Anyways, okay, I will try to talk about this diagram. So basically, we have a person all the way here. He pushes a test into Git. And after the test, after you push the branch into it, Git triggers a Jenkins job, which passes the branch name into the Jenkins job. Then Jenkins, for that job name, downloads that branch and all that code and runs all of the tests. It's hard to see, but basically we run RSpec, Cucumber, Selenium, everything.
This is a virtual.
Yeah, I know. It's the projector. I didn't think the projector is going to be that way, so we have this guy right here. We push to Git. And what Git does is it pushes to Jenkins. And we have so we trigger the guy after you push it to test. We run every single test against your branch, and if something fails, you know it right away. Now, the next step, though, if you do automatic merge, so instead of pushing to something that says test, we will take it a step further, and so when we push to something to merge, basically we will follow this procedure. If the tests fail in this procedure, then we just kind of ignore the build and let you fix it on your own time. If the tests are green, then Jenkins will call Git and say, okay, here's a new branch, merge it into master. When that happens, Git automatically triggers Jenkins again, saying, hey, master just changed. And then master triggers all those tests all over again. So now we not only, because what ends up happening is if you run all of our tests, there's so many, if you run them on your laptop, you're gonna sit there for about a day. So we started to use, we just bought a bunch of computers to use in Jenkins. We have 50 of them. And let you push to Jenkins and let the build take only 14 minutes instead of your laptop. But what happens is when 20 people push things at the same time, all of them are green individually, but when you finally merge them, something might break. And so we rerun everything at master again after we merged in everything else everybody pushed. So this happens constantly. This happens 200, 300 times a day. And so what we can keep a build green even with 100 people who are constantly adding new code. So that's basically the idea. Now, yes?
And if a conflict happens, how do you resolve it? So the developer has access to this branch resolve conflict.
So if a conflict happens, if the conflict happens early on, within when you initially pushed it, nobody's affected but you. So you just look at the branch, you fix it, and you push it again. When it runs green, it will auto merge. It's very rare, to be honest. Very rare. It only happens once a month where the conflict actually, all of them are merged together. The conflict happens because the fact that we're constantly pushing and constantly making sure that it's green, it's sometimes when it goes red, it's like it's something that nobody has even ever thought of, and somehow it's not through. But at that point, we will automatically revert to. I will take your branch and I will take everything out of the branch and revert it and tell you, hey, you broke this build right here, and let the person figure it out. But it's not a very often occurrence, so we don't really have to worry about it much. But yeah, so what I was saying though is, Anyways, what I was saying though is, I asked, I remember a couple of months ago, I sent a request to Team City saying, hey, why don't you guys do an automatic merge? Because they did something very similar to any branch in Team City where it was, instead of running the test locally, just push it and let Team City run it for you. So I said, hey, why don't you just, after you run it on Team City, merge it automatically? So they're working on it, and probably will be in the new version, which is kind of cool if you want to pay the money for the Team City. But you can build the same thing in Jenkins for free.
RSpec also free too.
RSpec is free, Cucumber is free, Selenium is free. The only thing you really need to pay for is computers. Huh?
Windows.
Windows, yeah. Well, no, like we, out of the whole development team, I think we only have 3 Windows computers. Yeah, and yeah, 2 of them are for testers, and 1 is in Jenkins to run the test against it. But yeah, usually the developers write on either a Mac or Linux, depending on what they want. And you can, like a lot of this. Again, if you're in a Windows world, yeah, you'll have to pay for a lot of Windows. But if you're lucky to only be writing a website and it's not a .NET website, hey, go with Linux. You're going to be a very, very happy person in a long time.
So it helps a lot of Explorer, which unfortunately.
Yeah, it's being used. And that part of the reason that we run Jasmine tests just for jobs. You guys are familiar with Jasmine? It's like a unit test for JavaScript, right? Yep. So we have to, and that is one of the most flakiest things ever. Like the guy who writes JavaScript, you know, we talk with him just about every day. Like, hey, you can't do that. You're breaking everything. Because like it's so easy to break Internet Explorer that it's like, don't do that. Stop.
How many versions of Explorer?
7 and 8. We're waiting to upgrade to 9, depending on how
What
many
you
people.
wrong?
Huh?
Because you skipped 5 and 6.
Well, yeah. So yeah, very true. And in our company, since our company is a web company and we purchase stuff, actually look at how many people come from which version of the browser and then try to get to them. We make sure that, you know, if you're in 6, you can still do things, but I think what we're doing right now is just saying, hey, you probably want to upgrade if you can, because Internet Explorer is really, really bad.
And how do you adjust your Autodesk for different browsers? Do you have separate tests or some configuration?
Usually, so we're using Selenium with Selenium 2 with WebDriver, and for the most part, they got WebDriver and Water, which is another, like it's a competitor to Selenium. They got them to a point where when you say something to do it, tell us something to do it, they will more or less act the same way in both browsers. However, there's certain things that once in a while JavaScript tends to be a little bit different, and so just make the test a little bit smarter, saying, hey, am I in Firefox now? Then click. If I'm on the Internet Explorer, then push, things like that. But the same test that run on one should run on the other.
So it's equivalent to
Huh?
It's inside of
Yeah, and again, it's this day and age, it's very, very rare. Like if you use WebDriver or Water nowadays, you can even get like Internet Explorer 6 passing most of the time pretty well. So it's a good place to be compared to a couple of years ago. It was Selenium 1, and you had to almost write 2 different tests for just to make it pass in Internet Explorer. And it's for the most part, we just said no, we're not going to write automatic tests for Internet Explorer because you will spend 2 times more time writing them, and you will not going to get much more better results out of it. So we would only write it for Firefox. But now WebDriver is mature enough that you can run it against Safari or Chrome or Firefox or Internet Explorer, and all of them pass when they should and fail when they shouldn't. So yeah.
Just one additional question. It says that you support 7, 8, 9 version. Do you keep 3 this browser on 3 different environments? You find the way to just run the Explorer?
Yeah.
I just by asking because 9 Explorer just having the debugging tools possibility to run in 7 and the 8 engine, and this engine mostly just the same as you will keep the different version.
There's a to answer the question of how to get multiple browsers. There's a company called Sauce Labs. What they do is basically they have a whole bunch of computers in the Amazon cloud, and you, instead of saying run local, start a local browser, you use their little adapter, and it says I'm going to start a browser, like I need Internet Explorer 6 on Windows XP, and so they spin you up a VM, and then you run a test against it. It's a little bit smaller, slower, but you get all these browsers, and you don't have to actually pay for them. It's a paid service, but you don't have to maintain the computer and make sure that the computer's up to date. So that helps out with just many browsers. But locally, when we just run for a regular build, it's Windows XP with Internet Explorer 8, and there's ways to install it to 6. But it's just weird. So yeah, usually if you want to do that, you probably need to get another machine or another VM or something like that. Otherwise, for some reason, when you install 7 and 6 at the same time, 6 are absolutely weird. Then it's better.
But you say you don't not have necessary to support 6.
Mm-hmm.
So if you have, for example, Windows 7 with the 9 Explorer, you can run. You can try to find the way to run the one instance of browsers on the different engines. This is just embedded functionality.
Well, still using Windows XP because I don't like this step set, to be honest. It's easier to just install it with Windows XP, to be honest. So it doesn't break as easily.
I have a question about Cucumber and RSpec. I'm also a Rails developer, and I'm thinking now about what to use, Cucumber or RSpec. As for me, these things are very similar. They are both DDD tools.
Yeah.
And what things do you test with Cucumber and what with RSpec? Could you please explain?
Well, it really depends. Like RSpec is a little bit more compact and a little bit more developer friendly, so we do tend to write equivalent of unit test in RSpec. Cucumber, so it doesn't really matter which one you choose. Just choose whichever one you feel more comfortable with. But if you want to use your tests and like if you want to develop the test together with your clients or with somebody else, Cucumber is very friendly because you write it out and just say, hey, given I'm Google.com and I type in hello world and I click search, and it's literally written out and it's very easy to read. So if you want to work together and just like write out a test ahead of time and just show it to your customer and say, is this what you want? They're like, yeah, that describes it. Or no, it needs to find this. So Cucumber is really good for that. But
Yes, but RSpec is more useful.
RSpec is much more, developers like RSpec a little bit better because it's more code and less language. So I've noticed that developers really like RSpec because it's just like writing a test and just any unit test or whatever. It's a lot of brackets, a lot of squiggly signs, a lot of everything. So the kind of developers like that a little bit better.
RSpec. I didn't fully understand the life cycle of feature in the Git. So,
one time? Fisheye and Git?
Life cycle of feature. Feature in the Git. So I'm a developer. I got new feature. I should implement it. I create branch in Git. So I code it. Then I create one more branch for each test.
One branch for each test?
Yeah, you.
So you're asking about the way we do branches?
Yeah, I didn't understand.
Okay,
why
so when we believe in trunk-based development, so when we have all the code base here, what I will do is when I want to start to develop a new feature, I still develop it in the trunk, right? I'm still doing it here. But when I want to just run a test against it, I will push to a new branch, but it's this code, and the test will run in that branch. And usually, after the test pass, we just delete the branch right away because if we just ran the test against it, it will run because we're technically running it against master. If we're running a merge test, it's going to merge into master right away, and we delete the branch right away. But basically, everything you write is going to be on the master. So the branch is basically just a way of saying, hey, I have master plus 3 new features and 4 new tests. Can you try to run them together? If it works, hey, it works. If it doesn't, it fails. But the idea is you stay on master and you don't try to split up into a different branch, any branches. So does that make sense? Like I feel like I didn't answer your question.
I didn't have experience with Git. That's why.
Okay, fair enough. What are you using?
SVN.
SVN?
So that's why it's.
Okay, fair enough. And it's a little bit different metaphor than SVN in that in Git it's very easy to make branches and you have the idea of origin and master. So origin computer and your laptop, which both try to stay the same, but they're you develop in your laptop and then you basically throw everything from your laptop onto the origin so that everybody else can see it. In SVN world, it would be like you have trunk, and when you write a new feature, you're writing it in the trunk. Yeah, but
I create small branch and.
Yeah, see, like in SVN, it will not work as well. In the SVN, it will be you make a branch out of the trunk, write the thing, and then let the test run against it, and let the branch merge back into the trunk.
Yeah.
So yeah, in SVN, it will be a little bit different.
What about features which cannot be fixed in a few minutes or a few hours? If this feature takes about a week to implement, and after this week, probably we have absolutely different trunk, and let's assume that we merge without any conflict. But if anything goes wrong, actually, if the build goes wrong. Who is guilty in
need?
Well, okay, so in our case, every single feature that you're developing in, even if you're only 10% done developing it, it still lives on trunk and it goes to production. We just feature flag it off. Like you just say, we have a file that says, oh, this feature is still off, and then when it's ready, we turn it on, and everybody can see it. But the code that for that feature was living in production, a couple of months now.
So if the feature takes more than one, I don't know, than X hours, I still have to commit it in trunk.
Yes.
But then it's some kind of mechanism which enables it.
Yeah, and in that case, like if I'm working on a feature that is still off, but I break everybody else's build, then anybody who's available will try to fix it. But the first person who tries to fix it should be trying to fix. Like usually, you find the person who made that feature and say, "Hey, you're doing something different than everybody else. Can you fix it?" If that person is not there, then next person tries to figure it out. If like I'm the only one there and nobody else is, like everybody went home, I just revert it right away. So, but the long-lived features sometimes. When you make a whole lot of changes and you just have to put it on a separate branch, we still run it, the new feature branch that lives for about a month or two, we still run the whole suite against them. It's just that it's not going to be in trunk. We run it as a regular any branch test. You just don't merge it, but we pull from master all the time into that feature so that it's always up to date.
Okay, yeah. Just one additional question. Do you have automated functional testing, or you have some automated design testing?
Functional testing, I don't think. Design testing, I'm not sure.
Yeah, no, I mean that you have some design changes. You checking manual. UI.
Yeah. So Selenium takes care of it for us.
Selenium checking design changes.
Yeah, so the new version of Selenium, the webdriver, for example, back in the day, if you have like a button that was like right here, but for some reason this header did this to it, you can still click the button. In the new version of Selenium, if the button is not visible, you will say, hey, I cannot click it, or if the button is over here, you will say, hey, I cannot click it. So,
even if it's not click it, if you just move it little, but if this is will make the design complete, you still have passed the test, but what is the case? I mean,
yeah.
How are you resolving this?
I mean, so we have people, like it's a very difficult question for like how do you test GUI, how do you test to make sure that everything looks pretty. Like I don't think you can actually write a test that checks that everything looks pretty and looks good. Like the only thing you can test is that, hey, I cannot purchase because the button is over there. So we can at least make sure that that doesn't happen. Sure, it will look ugly, but at least we can let the customer purchase or let the customer do what they want it to do, even though it's a little bit ugly. But somebody actually has to consider that. That's where the manual testers come in. They look at the stuff, they like make sure that everything's pretty. Once in a while when it gets ugly, you say, hey, you broke the button, it was wrong color. So, but I honestly don't know if there's a way to make sure that something is pretty versus something is ugly. I mean, how can a computer know? So, I'm not sure.
Probably you should just define criteria of pretty.
Yeah, and it's like at that point, you might as well write a computer system that's so smart that it's going to kill you because it's smart enough to kill you.
Yeah, I can see this movie.
Yeah, there was a movie about it. So.
Yeah.
Any more questions? Yeah. Yeah. Perfect.